So what we're going to take a look at, there's general solubility guidelines that you have on the paper that you're giving out. They're also on page 437. So if you have your book, you can look on page 437, and they have what's called general solubility rules. They'll be about the same as what was given out on that table. Okay? What I'm going to do is describe to you a little bit about what we mean about something being soluble. Okay? I'm going to draw a picture here. So we got a beaker here, and it's got water in it. H2O molecules. So I'm just going to put H2O instead of drawing out the individual structures. So we got H2O in here. It's going to be the solvent that we're going to have. Okay? And so let's say everybody knows that NaCl dissolves, right? Salt. You guys agree with that? Pour salt into something, it's going to dissolve. Okay. So that's a solid, and when we pour it in here, what happens is the water attacks the crystals and pulls off the sodiums and pulls off the chlorines. They just go in there and pull them off. So then what we end up with is ions, individual ions floating around in here. Okay? That says that this is soluble. Okay, when we do that. So when we just put it in water, if it dissolves, we say it's soluble. Okay? The S behind NaCl does not stand for soluble. What does it stand for?
Solid.
Solid. So solid, we pour it in. After we pour it in, what is the symbol that we would use behind the NaCl after we pour it in?
AQ.
AQ. So now it's aqueous. See, solid, mixture, aqueous. It's all dissolved in there. Okay? So then we got this other compound that's AgCl. I want you to find on your number 3 statement. Okay? Number 3 statement. What it will say in the book, which is real similar to what you have, it'll say most chlorides are soluble except for silver, mercury, and lead. The one I gave you out says it just a little different. It includes some other elements. It says most chloride, bromide, and iodide salts are soluble. Exceptions are if you have silver, lead, and mercury. Okay? So when we pour this in to water, it says that it's insoluble because it's one of those exceptions. It says, hey, chlorines are soluble, or chlorides are soluble, but if it's paired up with a silver, mercury, or lead, it is insoluble. So it's not going to break apart into ions. It's going to go to the bottom, and it's going to just sit there because it's more dense than water. So it's just going to sit at the bottom of the beaker and not dissolve. So we say that this one is insoluble. Any questions? That make sense? All right.
Only when it has silver, lead, and hydrogen.
Right. So there are some of these elements that say, hey, most of the time they're soluble, but here are some cases where they're not. Josh.
Are they soluble if they're like, okay, so it says like lead with a +2 charge, or if it was a +4 charge, could it be soluble?
It's a good question. Most of the time it's going to be a +2. So we're going to work with ones that are just +2. So that was a very good question. We'll just deal with ones that are +2. Okay. I got a new car. All right.
She like wanted to give you the lanyard, but you didn't know to take the lanyard.
Okay. So what you'll need to do is practice determining if something is soluble or insoluble. Okay? And so I'm going to give you a list of 7. And you're going to put those in your notes, and then you're going to look at your chart, and you're going to read through the statements. And you're going to say, hey, if this element's present, it's going to be soluble. But if this combination's not there, it's insoluble. Okay, and that's how we'll practice. We'll just do trial and error. See if you guys can read the chart. If you look at it, NA is on your chart, and if you look on the second statement on there, on that table, it says that most salts containing alkali metals, guess what? Sodium's one of them. It's soluble then. Okay? It says most are soluble. Chlorine. Third statement. It says most chlorides are soluble. So we say it's soluble. Now, so here's the rule. What if you pair up an ion that says it's soluble with an ion that says it's insoluble? You're always going to say they're soluble. You're always going to say they're soluble. So the soluble one always wins out over the insoluble. All right? For example, let's take a look at an example here. If we have Na3PO4, so we look up Na, and the second statement says Na is going to be soluble. And then we look down at statement number 6. It says most, and then you go all the way to phosphates. Most phosphates are only slightly soluble. Well, sodium's soluble, phosphate's insoluble. You always go to the soluble, always wins out. Always wins out. Okay? If it says it's slightly soluble, okay, combination. If it says these compounds are slightly soluble and sodium's not present, you know, we're going to say that they're insoluble. So anytime it says slightly soluble, like, for example, if we had CaS, calcium sulfide. We find S, calcium's not on there, but we find S, and S is on number 6, and it says those sulfides are insoluble, or slightly soluble, at the best. And so we're always going to put a solid with ones like that, and if it's aqueous, we're going to write an AQ. If it's aqueous, we're writing AQ.
How do you know if it's aqueous?
If it's soluble, it says these are soluble. AQ. They dissolve. Okay? Alright, so here's your list. We'll see if you can do this. So there are 4 examples that you can look at and determine if they're soluble or not. All right? Carter, what did you get for NH42SO4?
AQ.
AQ. What did you look at on your list?
It says on number 2 that and the
Ammoniums are soluble.
Yeah.
Now, do you have SO4 listed on there too? Is there SO4 listed? Yeah. Statement number 4, right?
Yes.
It says most sulfates are soluble. And so right there it tells you as well. They have 4 exceptions though, but ammonium's not one of those exceptions. So you'd put an AQ in there. AQ. Alright? Josh, what'd you get for KNO3?
Soluble.
Soluble. What did you look at? What number?
2 and 1.
2. 2 and 1. They both support its aqueous. So it's aqueous at that point. Okay? Kendall, what'd you get for CaSO4? It would be if it wouldn't be a combination with calcium. Because if you look at statement 3, it says, or 4, it says most sulfates are soluble. But here are 4 exceptions. And calcium is one of those exceptions. So if it's an exception to being soluble, that means it's a solid. Is there any questions on that? Okay. So we're just learning how to read this list, seeing if it's soluble or insoluble, kind of going through that way. Hunter, what'd you get for calcium carbonate? You got a solid or AQ? Solid. And what did you look at for that? Okay, yep. Most of those carbonates are only slightly soluble. And it's not paired with anything in number 2. So we say it's a solid. We say it's a solid. Kyle, what'd you get for K2S?
Aqueous.
Aqueous is right. Even though it says most sulfides are insoluble, or only slightly soluble, guess what it's paired with? K. K is soluble. So we're going to make it soluble. And then CaOH 2. Megan, what'd you get for that? Solid. Very good. Most of those hydroxides, if they're paired with like sodium and potassium, they're soluble. You get them combining with some other things that they're insoluble. All right? Questions or thoughts on that? So that's the first step of doing these problems correctly, is to use your chart. Again, you can find it on page 437. All right. Well, that gets us to doing chemical reactions. They're called double displacement reactions. So with that little bit of information, we're going to go ahead and show you what's called a double displacement reaction. Okay? So this is what a double displacement would look like. This is real simple. We have AB plus CD. A is plus, B is minus. These are ionic compounds, all of them. Plus, minus. What's going to happen is either these are aqueous, and what they'll do is they'll switch places. So the A will come in and switch places with the C, and the C replaces where the A was originally at. So the positive ions replace, and so we would make a compound AD plus, what would be our other compound? CB, just because we always want to put the positive first. Now, to have a reaction, one of these two would have to be a solid. The other one could be aqueous, but one of the two would have to be a solid. Now, you guys already know how to determine solids. They're insoluble. So let's do an example. Okay? Here's our example that we're going to do. You're going to have to write the products out, though. Okay? So I'm going to have Ki, which of course is aqueous, and I'm going to put it with a solution of PbNO3. And it is also aqueous. Right? What you need to do is look at the example up above, switch places with the positive ions, and then make sure the charge is balanced. So you got to have your polyatomic ion out, sheet out. I think I'll help you with this one. I'll put their actual charges above them here. And then go ahead and write the products correctly. Right? And then we're going to look at that chart to determine if any of them form a solid or not at that point.
Wait, do we change it before we...
Okay, so when you rewrite them, I'm just going to rewrite them down below. I don't have enough room, so we're going to extend that arrow like it's down below here. And we're going to write K with NO3. And we notice the charges are the same and opposite, so we just need one of each. Okay? Then I'm going to have to determine here if it's a solid or aqueous based upon what we did earlier. Next thing I'm going to do is I'm going to put PB with I, and realize that PB is a +2, iodine's a -1, so we're going to make it PBI2, and then we're going to put a parentheses around it to see if it's a solid. Is there any questions on that? That makes sense? You're just putting the ions together. Now, to balance it out, we would put 2, let's see, we would have to put a 2 in front of Ki and a 2 in front of KNO3, right? Now, balance it.
Oh. Doing that.
That balancing thing, yep. So now let's have you determine if it's an AQ or a solid. Maybe you've done that already. So use your list, determine if it's an AQ or a solid.
Will it start out where they're both always aqueous?
Yes, yes, good question. They always, okay, the KNO3 is aqueous. And the PBI2? Solid. Right? Because you looked at iodides and they're mostly soluble, but if they're with lead, it is a insoluble substance.
Second one, in the reaction, could they both be aqueous or one has to be solid?
If they're both aqueous, then what happens is we will say it's a no reaction. So if we come out and we put two together, it's like pouring these two liquids that I have up here together, and I don't see anything happen. They're just mixtures. If that happens, then it's called a no reaction. There's no reaction. There's nothing taking place. Nothing being rearranged. Everything in the same form. But if it's a solid, one of the two, then it's going to be one that we consider reaction, because the solid's being formed. All right. So most of you have got those written out, and we're going to go ahead and do that here. Na, we'll go with NO3, and since they're both positive 1 and negative 1, we would write NaNO3. And so is that aqueous or solid? Aqueous. Then we would write Ca with S. And S is -2, calcium's a +2. So we just write one of each. Okay? Some of you like doing this. You know what, I messed up. This should have been a 2 here. Okay?
That would have made it.
Yeah, that's my fault. I didn't put a 2 there. But put a 2 there. You still have your same combinations. Alright? So the Ca and S is a +2, -2, and then we just have to determine if it's insoluble or soluble. What is it?
Solid.
It's a solid, right? It's insoluble because the last statement says sulfides are insoluble unless they're with, like, ones in number 2. So we say solid. And then we balance it. And that's where I messed up on the CMF. There you go. There's your reaction. Formative solid. So I'm going to give you the next 10 minutes to write out 4 examples. And those 4 examples you can do, determine if reaction. Now, we didn't do one where it was a no reaction. We didn't do any that said both of them AQ. If all of them are AQ on the right side, we say, oh, that's a no reaction. And that can happen sometimes. Right? So
You can give us any of those?
you might have one of those in this group of 4 that you're going to have to do. So here's going to be the 4 I want you to do.
Are we getting this in or can I have my notes?
You can put it in your notes, be fine. That would be A-okay to do that. I'm not going to write aqueous on. Well, I guess I will. There's something else I got to write, but I'll do it. Then you draw your arrow, of course. Then I'll write the 4th one on the next page. So once you get those down,
So lead, if something's with lead, it's not soluble at all, right?
I think there's some things that, yeah, lead are soluble. With nitrates, they're soluble. So that'd be the last one you write. That'd be the 4th one you write down.